Welcome to The Explainer. Today, we are diving deep into one of the most fascinating corners of AI, reinforcement learning. We're going to unpack what it is, why it's so different, and how it actually works, all in a way that just makes sense. So here's our game plan. First, we'll talk about why we even need reinforcement learning. Then, we'll use a super simple analogy to get our heads around the main idea. From there, we'll break down the key parts, connect all the dots, and then wrap up with the one thing you absolutely need to remember. All right, let's jump right in. To really get a feel for reinforcement learning, you first have to understand the kind of problem it was built to solve. It's a little different from what you might be used to. I mean, think about it. How do you learn a skill when there's no instruction manual? Like learning to ride a bike for the first time or figuring out a really complex video game. There's no book that can tell you every single thing to do in every possible situation. No teacher can give you all the right answers up front. So, what do? Well, you learn by doing, right? You just try things, you see what happens, and you adjust your approach based on what you learn. And that is the absolute core of reinforcement learning. It's all about creating something, an agent, that can figure out how to win in a complicated world, not by being told what to do, but by learning from the consequences of its own actions. To make this idea really concrete, let's step away from the computers and into the kitchen for a minute. Imagine an ambitious chef who wants to create the world's greatest dish, but has zero recipes. Okay, this comparison really nails the difference. Supervised learning, that's like being a line cook. You're handed a perfect, detailed recipe, and your job is to follow it exactly to make a dish you already know is good. But reinforcement learning, that's like being the head chef. You're experimenting, you're tasting constantly, you use that feedback to figure out what to do next. You're not just copying a dish, you're discovering it. So, how did this very intuitive idea of learning by doing get turned into something computers can use? Well, the story actually begins in a pretty unexpected place. Not in a computer lab, but in psychology labs almost 100 years ago. You see, this whole concept of learning from consequences is nothing new. It goes way back to Pavlov's experiments with dogs, where the word reinforcement was first used. Then you have Thorndike's law of effect, which basically said, hey, if you do something and good stuff happens, you're probably going to do it again. It wasn't until the 60s that people like Minsky started thinking, wait a minute, could we make a computer do that? And that's what eventually led to the incredible AI we have today. So to build this into a system, we first need our learner, our decision maker. In the lingo, this is called the agent. Every single RL problem has an agent at its heart, a robot, a game-playing AI, you name it. And in our analogy, the agent is, of course, our chef. Now, the agent doesn't just exist in a void. It operates inside an environment. This is just everything else, everything the agent can interact with. For our chef, the environment is the whole kitchen. The stove, the food, the pots, the pans, all of it. And the interaction between these two creates this constant, simple loop that is the engine of all learning in RL. It goes like this. The agent, our chef, takes an action, like adding some salt. The environment, the kitchen, updates its state. The dish now has salt in it. And then, most importantly, the environment gives back a reward, in this case, the taste. This loop, action, state, reward, just repeats over and over. That's it. That's how learning happens. But this simple loop brings up a massive, massive challenge. It's a puzzle that Minsky pointed out all the way back in 1961. He called it the credit assignment problem. Just think about our chef for a second. Let's say after hundreds of little actions, the final dish is absolutely perfect. Amazing. But which action was the one that made it so good? Was it that last-second pinch of salt, or was it something you did an hour ago, like searing the vegetables just right? Figuring out which of your many, many past actions deserves the credit for a future success, well, that's the whole ballgame. And it's what RL algorithms are built to solve. So how on earth do agents solve this problem? Well, they tend to use one of three main strategies. A value-based agent tries to learn how good it is to be in any situation. Our chef might learn that the state of onions gently simmering is an 8 out of 10 situation. Things are looking good. A policy-based agent, on the other hand, learns direct instincts. It's like developing a cooking style. If the food tastes bland, my go-to action is to add something acidic. Then there's model-based, where the agent actually tries to build a mental simulation of the world. Our chef basically becomes a food scientist, predicting how ingredients will react before even adding them so they can plan ahead. Okay, now that we have all the pieces on the table, let's put it all together. Let's trace the whole journey from a simple idea about trial and error to the powerhouse AI we see today. So here's the entire story in 4 steps. It all started with an idea from psychology. Then that idea got formalized into this clean mathematical framework, an agent, an environment, and rewards. The central puzzle of credit assignment gets cracked by using one of those clever strategies: values, policies, or models. And finally, when you throw massive computing power and deep learning at it, this simple framework can lead to superhuman performance in incredibly complex tasks. So after all that, if you only remember one thing, what should it be? What's the real secret ingredient to all of reinforcement learning? It's this. Reinforcement learning is really all about finding the best strategy or policy, not because someone gave you the answers, but because you figured it out for yourself by learning from the results of your actions. It's optimization through experience, plain and simple. And that really leaves us with a pretty mind-bending final thought. If this approach can allow an AI to teach itself to master a game as complex as Go with no human instruction, what else is out there? What other huge, messy, real-world problems in science or medicine or engineering could be solved by an AI that just learns by trying things out in the world?